Jai Hind all of you. I am Ritika Dhyani, working as an assistant professor in Ajay Kumar Garg Engineering College. So in today's video lecture, I'll be discussing the topic locking protocol that will be used in database management system. Moving on to the, first of all, we should know about the concurrency control before moving on to the locking protocols. So concurrency control, it is the working concept that is required for controlling and managing the concurrent executions of database operations and thus avoiding the inconsistencies in the database. Thus, for maintaining the concurrency of the database, we have the concurrency control protocols. It is a mechanism in DBMS that allows simultaneous execution of transactions while maintaining asset properties. Asset properties as in atomicity, consistency, isolation, and durability. It maintains the integrity, accuracy, and reliability of data when multiple users or processes perform read-write operations concurrently. It helps managers issues like conflicting operations on shared data. See, whenever any issue arises, it is the required condition that it must be on shared data variables or shared object only. Secondly, it inconsistent database states and lost or incorrect updates. So these are the issues that will be managed by concurrency control protocols. Why do we need concurrency? This is the question that we all have in mind before moving on to the next topic. So let's say we have a scenario in which there is a withdrawal must be happen or a transfer of a certain amount is needed from one account to another. So initially, first account will be having $1,000 and the second account is also having $1,000. So when first transaction happen, it withdraws $200. So what it do? It reads the available balance firstly and then calculated the new balance. New balance will be the 1,000 minus 200, that will be $800 for this particular scenario. Same happens with, so here we have without concurrency control, here we have concurrency. So in this case, this first step will be the same only. When second transaction arrives, it withdraws $300. So it again reads $1,000 because this $800 is still not updated on database. So it reads the balance that it is still $1,000 and it deducts $300 from it, and the now available balance will be $700 for this particular scenario. But when we talk about the concurrency control, then what happens is the second transaction wait until the first transaction permanently stored in the database. Once transaction A commits, reads updated balance, $800 calculates new balance will be the 800 minus 300, that is $500. Finally, in this particular scenario, when A writes $800 and B overwrites it with $700, so here lost update issue problem occurred. So this is the incorrect or inconsistent answer or the final balance in real scenario without concurrency control protocol. But when we use concurrency control, in this case, this when A writes it 800 and then B transaction update it with another 500, then this will be the final or correct value. So it seems that this particular database is in consistent state. So it prevents conflict between simultaneous transactions. Here you can see both the transactions are happening parallelly. Maintain data consistency and accuracy in multi-user environments. Avoid problems such as dirty read, lost update, and inconsistent reads. What are these problems basically? Dirty read is nothing but a transaction reads uncommitted data from another transaction that may later roll back. Lost update will be the two transactions update the same data and one update override the other. And in the third one, inconsistent read, a transaction reads the same data multiple times and the data changes in between the read operation. Next is the protocols that will be starting in concurrency control. So these protocol ensures the atomicity, consistency, isolation and durability along with the serializability of the concurrent executions of database transactions. Therefore, these protocols are categorized in the following: lock-based concurrency control protocol, timestamp concurrency control protocol, and the last one is validation-based concurrency control protocol. In today's video lecture, I'll be discussing the first two control protocols here. So, first of all, lock-based protocol. In this type of protocol, any transaction cannot read or write data until or unless it acquires a appropriate lock on it. There are two types of lock. First one is shared lock and the second one is exclusive lock. In shared lock, it is also known as read-only lock. The data item can only read by the transaction. It can be shared between the transactions because when the transaction holds a lock, then it can't update the data on the data item. So this is the scenario where shared lock will be used. In the second one, exclusive lock, it is the read and write both this particular lock can access both read and write operations. This lock is exclusive, and in this lock, multiple transactions do not modify the same data simultaneously. Wherever in shared lock, we can do this particular task in parallelly. Next is, there are four types of locking based protocol. First one is simplistic lock protocol. In this, the locking is done while the transaction is still happening. Simplistic lock-based protocol allow all the transactions to get the lock on the data before insert or delete operation or update operation. It will unlock the data item after completing the transaction. In the second one, pre-claiming lock protocol, it evaluates the transaction to list all the data items on which they need the lock, firstly. Second, then before initiating an execution of the transaction, it requests for all the locks to DBMS to lock all these data items. If all locks are granted, then this protocol allows the transaction to begin. Otherwise, when the transaction is complete, then it releases all the locks. But if all the locks are not guaranteed or granted, then this protocol allows the transaction to roll back and wait until all the locks are granted. Next one is two-phase locking. In this, the two-phase locking protocol divides the execution phase of the transaction into three parts. First one is where the execution of transaction starts. It seeks permission for the lock it requires. Second phase, the transaction acquires all the locks. In the third phase, as soon as the transaction releases its lock, first lock. In the third phase, the transaction cannot demand any new lock. It only releases the acquired lock. So there are basically two phases in this particular protocol: growing phase and the shrinking phase. In growing phase, new lock on the data item may be acquired by the transaction, but none can be released. While in shrinking phase, no new lock can be acquired, only releasing of locks is done in this particular phase. In the below example, if lock conversion is allowed, then the following phase can happen: upgrading of lock from growing to shrinking, or downgrading of lock in shrinking phase. Lastly, strict two-phase locking protocol. The first phase of this particular protocol is similar to 2PL only. In the first phase, after acquiring all the locks, the transaction continues to execute normally. The only difference between 2PL and strict 2PL is that strict 2PL does not release a lock after using it. It waits until the whole transaction commits and then releases all the locks at a time. Strict 2PL protocol does not have any shrinking phase. Next one is timestamp ordering protocol. In this particular protocol, it enforces that older transactions with smaller timestamp obviously are given higher priority. This prevents conflicts and ensures the execution is serializable and deadlock free. For example, if transaction T1 enters the system first, it gets a timestamp of, let's say, 007, and T2 after entering T1, it gets a timestamp of 009. So it means T1 is older than T2 here. So obviously priority is given to T1. The basic timestamp ordering protocol works by comparing the timestamp of the current transaction with the timestamp on the data item it wants to read or write. Suppose if an old transaction Ti has timestamp Ts bracket mein Ti, new transaction Tj is assigned timestamp this particular such that timestamp of second transaction is higher than timestamp of first transaction. That means this is the older transaction. The protocol manages concurrent execution such as the timestamps determine the serializability order, in which order these transactions will be happening. The timestamp ordering protocol ensures that any conflicting read and write operation are executed in timestamp order only. Whenever some transaction T tries to issue a read operation or write operation on a particular data item X, the basic timestamp ordering protocol algorithm compares the timestamp of T with read of Ts, X and write to ensure that the timestamp order is not violated. Two basic timestamp ordering protocol are discussed here. Whenever transaction T issues read operation on particular data item X, it checks the following condition: whether write is greater than timestamp of this particular transaction. If it is true, then abort the transaction, else allow the read operation and set the read timestamp of particular transaction as maximum of read or the transaction itself. Second condition is whenever a transaction issues write operation, it checks that if the read operation is having the greater timestamp or not, read or write both check. If it is true, then abort the transaction, else allow the write and set WTS equals to TST. When conflicts are detected, the younger transaction is aborted and it is rolled back. Moving on to the advantages and disadvantages of concurrency control. So here you can see on advantages, it reduces the waiting time because multiple transactions can proceed simultaneously. Improved response time because faster accesses and interaction can be done in database. Better resource utilization. As you all know, hardware and database resources are efficiently shared in this particular case because multiple transactions are running at the same time. So better resource utilization is there. Next, increased systems efficiency. Higher throughput and better overall performance is there. Moving on to the disadvantage, as it heightens the overhead. Managing locks and timestamp adds another overhead to the system. Deadlocks, circular wait between the transaction can halt the progress. Reduced concurrency, locking can limit the number of simultaneous transactions. Complexity, implementation in distributed or large system can be difficult. And at last, inconsistencies, rollback or long waits may cause temporary data inaccuracy or staleness. Next topic is multiple granularity. It can be defined as hierarchically breaking up the database into the blocks which can be logged. The multiple granularity protocol enhances concurrency and reduces lock overhead. It maintains the track of what to lock and how to lock. It makes easy to decide either to lock a data item or to unlock the data item. This type of hierarchy can be graphically represented as a tree. So let's say we have an example here. Consider a tree which has 4 levels of node. First level shows the entire database. Second represent the node of type area. The higher level database consists of exactly these areas. The area consists of children nodes which are known as files. No file can be present in more than one area. Finally, each file contains child nodes such as record. So here you can see This is the database. Then this database is divided into areas, and these areas will be having some files, and a file will be having some record, right? So in this example, the highest level shows the entire database here, and the level, another levels are area, files and records. Intention mode lock. So firstly, intention shared lock. It contains explicit locking at a lower level of the tree, but only with the shared locks. Second is intention exclusive. It contains the explicit locking at a lower level with exclusive or shared lock. And at last, shared and intention exclusive. In this lock, the node is locked in shared mode and some nodes is locked in exclusive mode by the same transaction. So, transaction T1 should follow the lock compatibility matrix. It firstly locks the root of the tree. It can lock it any node. If T1 currently has a parent of node locked in the either IX or IS, then the transaction T1 will lock a node in S or IS mode only. If T1 currently has a parent of node locked in either IX or SIX mode, then the transaction T1 will lock a node in X, SIX or IX node only. If T1 has not previously unlocked any node only, then the transaction T1 can lock a node. If T1 currently has none of the children of the node locked only, then transaction T1 will unlock a node. Observe that in multiple granularity, the locks are acquired in top-down order and the locks must be released in bottom-up approach. If T1 reads a record RA9 in a file FA, then transaction T1 needs to lock the database first, then area A1 and then file FA in IX mode. Finally, it needs to lock RA2 in S mode. If transaction T2 modifies record RA9 in the file FA, then it can do so after locking the database area A1 and file FA in IX mode. Finally, it needs to lock the RA9 in X mode. If transaction T3 reads all the records in the file FA, then transaction T3 needs to lock the database and area A in IS mode. At last, it needs to lock FA in S mode. If transaction T4 records the entire database, then T4 needs to lock the database in S mode. Thank you.